Hi, my name is Karen Carter and I am one of the distance learning students. This presentation is an overview of Chapter 7 from the book The Tangled Web. Chapter 7 covers non-HTML document types. Although this chapter is small and somewhat, dare I say, dry, I did learn a lot from it, and I will share these moments with you as I go along. For some they will be, "How could you not know that?" And for others they will be, "Thanks, I didn't know that either." HTML is not the only file format recognized and displayed by the rendering engines of our web browsers. Right now there are about a dozen other file formats, and this list is likely to grow over time. This is one of my learning moments. What is a rendering engine? A rendering engine, also known as a web browser engine, is a software component that takes marked up content such as HTML, XML, or image files and formatting information such as CSS or XSL and displays the formatted content onto the screen. This is a list of the non-HTML file formats that are covered in Chapter 7. The first non-HTML document is a plain text file. Plain text files are recognized by every single browser. Their input is displayed as is, typically using a non-proportional typeface. All browsers recognize plain text files served with the content type text/plain in the HTTP header. For all browsers except Internet Explorer, plain text is the fallback display method for headerless HTTP responses and data where the content type is missing. Internet Explorer falls back to HTML rendering. Most browsers will automatically map several MIME types to plain text. Some are listed here. There are no specific security consequences in plain text rendering. However, the book does state that due to poor design decisions in other browser components and in third-party code, harmless non-HTML formats are at risk of being misidentified. For example, they may be identified as HTML. It also states that attacker-controlled plaintext documents are of special concern because their layout is often fairly unconstrained and therefore particularly conducive to being misidentified. The next non-HTML file format we will talk about is the bitmap image. Browser engines recognize the same set of bitmap image formats that are normally supported in HTML documents when they are loaded with the image tag. Formats supported are JPEG, PNG, GIF, and bitmap, among others. When the bitmap image is displayed, the user is typically allowed to scroll, zoom in and out, and save the file to disk. In the absence of content type information, images are detected based on file header checks. When a content type value is present, it is compared with about a dozen predefined image types. However, if an attempt to decode the image fails, file headers are used to make a second guess. Therefore, it is possible to serve a GIF file image as a JPEG file image. Bitmap images are a passive resource and carry no unusual security risks. However, remember, whenever serving user-supplied images, the attacker will have a degree of control over the data, even if the format is carefully validated. Once again, there are concerns about document formats being misinterpreted by a browser or a plugin. Next, we will talk about audio and video. Browsers for a long time did not have built-in support for playing audio and video, except for the obscure BG sound tag in Internet Explorer, which to this day can still be used to play simple MIDI or WAV files. Due to the lack of cross-browser multimedia playback functionality, audio and video was almost exclusively the domain of browser plugins. The most popular ones around today are Windows Media Player, Adobe Flash, Apple QuickTime, and Microsoft Silverlight. There is ongoing work in HTML5 to change this through the support of audio and video tags. These tags are described as convenient, scriptable methods that interface with built-in media decoders. The debate is which video formats to support and what patent consequences this decision may have. For instance, many browsers already support Ogtheora, a free open-source codec. However, there are arguments supporting the H.264 codec and prospects of Google-backed WebM. Audio and video are passive media formats. Neither the BG sound tag nor HTML5 multimedia are expected to have any implications for web application security. Although, and here we go again, as long as the possibility of content misidentification is mitigated appropriately. However, there could be security concerns with the audio tag in HTML5 if it supports raw uncompressed audio data. Now we will talk about XML-based documents, which is uncharted territory for me. Another aha moment. XML was designed to transport and store data, whereas HTML was designed to display data. The transport part of XML intrigues me. I'll have to research that one further. XML is the largest family of browser-supported non-HTML document types, which rely on the common XML syntax. And based on the received content type value, several formats that belong to this category are forwarded to a specialized single-purpose XML analyzer. But more often than not, the payload is routed to the same parser used to render XHTML documents. When the payload is routed using the same parser as XHTML documents, the actual meaning of the document is determined by the URL-like XMLNS namespace directives present in the markup itself. This namespace parameter may have nothing to do with the original value supplied in the content type. The most common scenario will have the namespace defined only once, and it is attached to the top-level tag. However, you can insert any number of different XMLNS directives in a single file, which give different meanings to each section of the document, as you can see in this example provided by the book. The general-purpose renderer will also do its best to make sense of the recognized namespaces and assemble the markup into a single document object model representation. It appears in this example that the underline should have been red, and this did not happen. Also, if any of the recognized namespaces support scripting, those will execute too. There are some security concerns with XML-based documents. Because of the counterintuitive XMLNS handling behavior, content type is not a good way to control how a XML document will be parsed. Also, the presence of a top-level XMLNS directive is not a guarantee that no other data formats will be honored later on. Bottom line, any attacker-controlled XML-based formats must be handled with care and sanitized thoroughly. Now on to the generic XML view. If a valid XML document has no renderer-recognized namespace present anywhere in the markup, it will be displayed as an interactive, pretty printed representation of a document tree, as shown here. Of course, this is of no use to the end user, but it can be used to debug a problem. If there are multiple namespaces in the document and one is recognized by the browser, even if the top-level one is not, the document will be rendered differently. All markup that is recognized will work, and all unsupported tags will have no effect and shown as is. To demonstrate, in this example also found in the book, the namespace identified in the top-level tag does not exist. Even though hello has underlined tags, these will not be supported and the word hello will not be underlined. The next namespace is recognized by the browser. Therefore, the underlined tags are supported and the word world is underlined. The security concern here is the fault-tolerant approach to the rendering of unknown XML documents and the unrecognized namespaces. The book gives an example of an RSS feed. It states it would not be safe to proxy an unsanitized RSS feed, even if the format is routed to a specialized renderer and not subject to cross-site script risks. Any browser that does not have a built-in RSS reader may fall back to generic rendering and then find HTML buried inside the feed. Moving right along, we are now going to talk about Scalable Vector Graphics, or SVG. SVG is a quickly evolving XML-based vector graphics format. First published in 2001 by W3C, it is known for its integrated animation capabilities and JavaScript scripting features. All browsers except Internet Explorer prior to version 9 recognize the SVG file format, which is handled by the general-purpose XML renderer. An SVG image can be embedded into an XHTML document if the appropriate XMLNS directive is defined, or in a non-XML HTML5 document using a predefined SVG tag. The book provides a sample code for a vector image that draws a circle and displays a message when the circle is clicked. Here's a demonstration. What are the security implications of SVG? Several browsers will support the format being placed in a standalone XML document and then viewed directly or loaded onto third-party pages via the image tag. Although it is safe to load SVG images via the image tag, and in this case scripting should be disabled, it is dangerous to host user-supplied SVG data because all embedded scripts will execute on the hosting domain. SVG images will require careful syntax annotation to eliminate non-SVG XML/NS content from the XML container and to permit only certain types of markup in the remainder of the document. Now we talk about the mathematical markup language, or MathML. MathML allows mathematical symbols to be viewed on the web, just as HTML allows text to be viewed. In browsers that support the language, it can be placed in a standalone file or inline in XHTML or HTML5 documents. Unlike SVG, there are no real security considerations beyond those generically handled by XML. Now on to the XML User Interface Language, or XUL, pronounced Zool. The name Zool references the film Ghostbusters, in which the ghost of an ancient Sumerian deity called Zool possesses the character Dana Barrett and declares there is no Dana, only Zool. Since Zool uses XML to define an interface rather than a document, its developers adopted the slogan, "There is no data, there is only Zool." Hence the XML namespace at the very beginning of every Zool document. Developed by the Mozilla Project, Zool is a presentation markup language specifically for browser-based applications rather than documents. It is only supported by the Firefox browser and is handled by the general-purpose renderer based on the XML/NS namespace. From a security perspective, Zool documents can be considered equivalent to HTML documents. Zool does have JavaScript scripting capabilities and allows broad control over the appearance of the rendered page. Now we are going to talk about the wireless markup language, also known as WML. WML is an obsolete, optimized HTML syntax developed in the 90s by a consortium of mobile handset manufacturers and cellular network operators. WML is an XML-based language and is a part of the Wireless Application Protocol Suite, or WAP, which offers a simplified web-like browsing experience for pre-smartphone devices. WML did not become as popular as its supporters had hoped because the WAP services needed to be engineered independently of normal HTML content, and they had to deal with closed and underspecified client architectures along with carrier-imposed restrictions. WML has been displaced by smartphone technology, which uses fully featured HTML browsers. However, the language lives on and is still routed to specialized renderers in Opera and Internet Explorer Mobile. The security concern with WML is that in browsers that support this format, it is possible to use WML-based scripts. Two methods are used to achieve this: through the use of WML script, a JavaScript-derived execution environment, and through normal JavaScript. WML script depends on standalone files coupled with an extremely inconsiderate abuse of fragment IDs for an equivalent of a possible attacker-controlled eval statement. Last but not least are RSS and Atom feeds. Feeds are a way for clients to periodically pull sites of interest, such as their favorite blogs. Really Simple Syndication, or RSS, and Atom are two very similar and fiercely competing XML-based feed formats. RSS is said to be the most popular. There are specialized built-in RSS and Atom renderers available in Firefox, Safari, and Opera. To route an XML document to these modules is as simple as using the tags RSS or feed as your top-level tag. An interesting feature of both feeds is they allow a subset of HTML, including CSS, to be embedded in a document in an indirect way. An example of this syntax is shown on the slide. There are some security concerns with RSS and Atom feeds, since they do allow a subset of HTML to be embedded. The subset is not well defined, and some feed renderers may allow scripting or navigation to potentially dangerous pseudo-URLs. And more importantly, browsers that do not have built-in feed previews may render the file using the generic XML parsing approach. And if the feeds are not sanitized carefully, scripts can be executed. This list reiterates the security recommendations presented in this chapter. This concludes my presentation of non-HTML document types.